session today. What we're going to do this time is make 20 pounds of black powder, commercial grain powder. We'll start with the beginning procedures, and right through everything, take maybe a week to really, not that we won't be on camera for a week, but I mean it's a step-by-step process. And we'll be showing every measure you take, every step along the way, very clear and simple. I might mention at this time that it's illegal for a citizen to make black powder, or any kind of explosive for that matter. I have a Class B explosives license, so I don't have to worry about that, but you do. Particularly if anybody ever got burned or hurt, it'd be really illegal then. But you're going to do it anyway, I'm sure, so just be extremely careful. Make sure no possibility of anybody being around. Not that it's really that dangerous, but just as a possibility. It's always good to keep that in mind. The best thing if you have a grandmother or a grandfather, uncle, aunt, someone has a farm or a piece of property out in the woods, pretty far out, where there's no chance of anybody coming upon it, get close to it, and just let it ball mill away in the remote area. If it blows up, you lost the mill, that's all. But it's not that very extremely unlikely. It would be more likely if you'd be hit by lightning or something. The procedure will be starting off ball milling the charcoal and the sulfur together. The reason for this is not to particularly incorporate the two, just to make sure they're extremely dust-like fineness. The only way you can do that, well, you can do it by long milling times with the potassium nitrate included in the mix. But the nitrate tends to cushion and insulate the charcoal and the sulfur too from real fine grinding. Charcoal, as you know, is kind of brittle and it's very hard compared to the rest of it. And if it's mixed in with the nitrate and everything, with the nitrate 6 times as much nitrate as the other ingredients, there's a definite insulating effect, and it takes a long time to get the charcoal to an extremely fine condition. If you use charcoal it's already like dust, fine, just go right ahead and mill it from the beginning. But if you're buying airflow, there's something already pulverized. It's fine enough, but it's no good. It doesn't make very good gunpowder. So if you make your own charcoal, you're going to have to mill it yourself, and that means this process we're doing now. After, say, 8 hours of milling the charcoal and the sulfur, which is completely safe, so you don't have to worry about doing that at all. Then you add your nitrate and mill it again for another maybe 10 to 20 hours, depending. When it feels like dextrin or extremely fine, like cornstarch, something like that, then it's ready for pressing. At that point, we'll add 5% moisture, just plain water, mix it thoroughly into it, and then load it into our, looks like a canister type thing, and press it to a density of 1.75 grams per cubic centimeter. Then there'll be little separations in between, little aluminum discs. You see all this when we do it, and they looks like hockey pucks come out of this apparatus when we're done. It has a split down the sides, so there's no way you have to force it or hammer on it or beat on it. Just spread that crack, and then just everything drops out. These hockey pucks are dried thoroughly in the sun until they're just as hard as china, porcelain. Then you hand break them, just take a mallet, preferably a rubber mallet or something like that, and hold it in your hand or set it on a block of wood and just tap on it, and it'll shatter like crockery into rough, good-sized chunks. Then we'll run it through the grinding mill to grind it into small grains, and put it in another ball mill type affair. Tumbles with I use pool balls for the game of pool. A bunch of them in there, and there's holes in the insert in the mill, and as it tumbles and knocks the grains about, the grains fall through, and eventually you can get it all to different sized grains. This is similar to a principle way back in the 1700s. They had large flat sieves hung suspended up in the ceiling, and they put blocks of lignum vitae in there with the grain, the coarse grains, the rough grains, and then shake it back and forth violently, and the grains knocking together, the blocks knocking together, would break the grains see the descending sizes till the bottom is dust. And we'll be doing all that, and after that we'll tumble it for 8 hours, just to put a brightness and polish and everything. We won't put any graphite on, we don't need that. That's just for a slight moisture proofing. It's questionable whether it is, but it does make it load, in the case of firearms, makes it pour, load easier, and bear transport a lot easier. It doesn't tend, the grain don't tend to stick together in time, whereas they will without graphite. You put them in a jar and put them away for 6 months. When you take it out, they're all stuck together. You just give it a wrap and they're all loose again, but you don't get that with graphite. And we'll just take it step by step and follow along. And now we'll go out in the supply barn and put together our charcoal and sulfur and start it milling. And then we'll just kind of take it from there. Take a look around the property here. See, there's the magazine way out there. And come around here and there's the supply barn. Go this way. And there's the house, right? All the tube paperwork and different things. And no real mixing in there, but just all the paper goods. And we'll go into the supply barn. Take a look in there before we start. It's a little dark in here, I think. Maybe not. Okay. In the back is the hydraulic press we'll be pressing that cylinder with. As I keep supplies in there, chemicals. And over here is potassium nitrate. There's two different types. There's a greenhouse and the K-Power. There's about 0.75% more purity in the greenhouse, probably because they add anti-caking agent in the K-Power. But they both work really well. I use the greenhouse for gunpowder because they make it as pure as you can. And then all these barrels along the back is all chemicals, different things. And a trusty fire extinguisher, I get them all over the place. Good things to have. And see around here we have an old grinding machine and more shells and supplies, different things. And now we'll go outside and go from there. I've already got the proper amount for 5 pounds. In this bucket here, we're going to add, I've already got 5 pounds worth in here, plus about a couple of quarts of marbles. And then I'm just going to add this to it. It's a real messy operation right at this point. That's just the charcoal and the sulfur. I'm going to add this lid. The lid is a little rubber grommet. These type of buckets come with it. And it makes a nice seal. So there's no dust that gets out, or you just seal it right up like that. So I'm going to put it in that mill. Now first I'll go over here. Okay, so everything's all loaded in there and sealed up and rolling pretty good. So we'll leave that about running all day today, about 7 or 8 hours. And then tomorrow we'll come back and add the nitrate and do the same thing again. Okay, here's our charcoal all ground. All day yesterday, about 8 hours. Sulfur charcoal mix. Now we're going to add that to this barrel here, which this is going to be the barrel we're going to use for further ball milling. Again, it's messy, but yeah, dump that in there. That's 5 pounds. 5 pounds of charcoal sulfur, which means we need 15 pounds of nitrate to bring our mix up to 75-15%. Here's Here's the nitrate over here. I'm going to add this to it. This has already been pre-milled on my wheel mill in there. I'll show you that later. So it's pretty fine. It's about 100 mesh. As it comes from the fertilizer company, it's about like table salt, which of course is too coarse. And it takes forever to ball mill it down to that 100 mesh, so I do it in the wheel mill. I got a ways to go yet. I might add, when you're using a stainless steel wok like this for any reason out in the sunlight, be very careful not to leave it in the sun with any gunpowder in it, because the parabolic action, I have heard of a case where it ignited. It's just potassium nitrate is no danger, but if it was finished powder, I wouldn't be doing this. I'm going to go to an even amount. I'll go to 10 pounds. I'll go to 5. Okay, there's 10. 10 pounds. Okay. Dump that right in this bucket. It's going in there pretty good. You always spill a little. It seems to be a... Well, it goes with the lease, I guess. You just always spill stuff. As much as I try not to. Now we'll go with 5 pounds. That'll make the 15. There's probably a little bit of moisture in this. There always is. So I'll add just a pinch more to cover the moisture. Right? It's not going to make that much difference, but might as well do it for the boat. Okay, it's 5 pounds. I'll put just a pinch more for good measure. That covers any moisture weight from the counting in there. Dump this in. There's our basic mix. Kind of wet here this morning, but okay, now put this back in here. And it's that. Now I'll put some marbles in there. I'm all measured out here. I'll put plenty of marbles so there's plenty of milling action. We got a rubber grommet in here and it screws on. This is a cement, for mixing cement. You just fill it with the mix and then you'll roll it back and forth. I use it for ball milling. It works pretty good. This cap screws on. It's not so good if you get an ignition, but we're a remote area, so it don't matter. Okay, that's all ready to go. This and this. Okay, we'll go into the ball mill room, set it up in there. Okay, here's the ball mill room. Here's our composition here, all ready to go. What I do is I just put it in here. Pretty heavy. About 20 pounds plus the it's probably 40 pounds in there. And start this going. Here's the wheel mill I grind the nitrate on. I'll set that running so you can see how it goes. That's the way that works. Then I'll set this going and let it run for quite a while, and I'll check it until it's right, and be taking it apart again. Powder's finishing milling. You can hear it in the background. We're all waiting a few more minutes. I thought I'd try a little experiment. This is some gunpowder made with air float charcoal. I'm going to show that the importance of the porosity and structural makeup of gunpowder. This is just pretty finely ground. It's been ground for about 20 hours, I guess. And we'll ignite some just as it comes, and I'm going to mix a little bit of water with this here, so maybe 5% or so. Put a little bit in there and just mix it around. And some people think that the reason that it burns much faster with the water is because the charcoal soaks in the nitrate into the pores. But the pores are so small that they can't take in anything as coarse as nitrate, no matter how fine it is. The pores can absorb things on a molecular level like gases and impurities and things of that nature, smoke. That's why charcoal is so valuable as a purifying agent. But it can't take in things that are, I don't know what size it'd be, but things that are as large as potassium nitrate particles just can't be adsorbed. That's A-A-D, adsorbed, not absorbed. Because charcoal will absorb water like a sponge, but that's not the same as into the pores. Okay, this is, I probably put a little bit too much moisture, but I think you'll still be able to see the vast difference in the burning rate. Over here. First thing we'll try is this is just a plain, as it comes, very, very fine. Quite a bit there, like keep it flat. Then we'll try the other with the water and see if you can see any difference. I think you will. See, that's with airflow. It's not particularly fast, but spark there. I'm going to get my fingers singed. Okay, this is looking 5% more. Same powder, same thing. But now what's happened is the moisture gives it a granular texture. Kind of crumbly, like cake. When you make a cake, and there's all little holes all through it, so the flame can progress very rapidly. So even though water does actually dampen the speed, it's more than offset by the porosity, as you will see. Considerable difference. Some people think that's some kind of a trick. It's no trick. It's just a very simple principle, really. I'm going to put them in the ball mill out now and take the 20 pounds of powder that we've made and just get set up here to press it into a little disc. And we'll see how that operation goes. All the materials are out here for pressing this powder. I've added the 5% moisture. It's just about ready to go, but first we have to prepare this thing. This is an aluminum cylinder tube with a long split I cut down it. And I put these hose clamps on there to fasten it to contain it. Try to divide it up in like quarters. Nothing fussy about it, just approximate. There. And probably like that. The importance of 5% moisture is extremely important. You can't really press the powder properly without it because it's very difficult. It doesn't want to move. The dampened powder flows and moves around. It's like a plastic material under the pressure of the hydraulic press. And that's what you need. You need that flowing. It makes a better powder. It makes it get the proper density, which it's very difficult to do without it. So what you do, you put in about a level scoop. Drop it right in there. Then reach down and kind of level it out a little bit. And put in this. Another level scoop or another scoop. And move it around. Another disc. And you keep doing that. Your hands awful dirty, but you get used to that, I guess. This stuff. Also, a man once said you should always cast one eye towards heaven when you're working with black powder. Well, I don't really do that, but it might be a good idea. But this is very ignitable right now, extremely ignitable. But there's nothing I'm doing here that's going to hurt it any chance. Where they used to have most of the trouble in the old mills and stuff is one of the mechanics or somebody would start chipping away dried powder off the press ram or something, the press box, and of course that's suicide. Do that. You might get away with it for a while, but sooner or later, get it just right with the point of that chisel or something, and away it goes. It's happened many times. Well, a lot of times they had accidents when the big, huge edge runners, the stone wheels weighing up to 8 tons. In Europe, they were generally 3 tons or smaller, because they had the 1875 or 76, I forget which explosives act, which limited the amount of composition under the runners to 50 pounds. So they didn't need the great, huge runners like DuPont and Hercules, all these American companies, and Goex even today. And those runners, they're driven by water wheel, and eventually by steam, in the late about the turn of the century. And when you stop the wheels, they used to stop them on a leather apron, a couple of leather aprons, because if the powder caked a little bit, when you started the machinery back in operation, of course the water wheels have a tremendous torque. When they start to roll, they're going to go. So the wheels can't roll, they skid. And you got an 8-ton wheel skidding across the powder, you might as well just hit the trenches. They had a lot of milling house explosions from that reason. It led people to believe that the milling was dangerous in itself. Well, it is, but generally that was the cause. Or foreign tramp material in the powder, a pebble, for instance. Say a large pebble got in there, it would, the wheel hits it and stops, crunches it up, and you get a local heat source. Getting down close to the end, yeah. Get a little more. There's 10 pounds of powder weighed out in here. This goes into this cylinder. It's all got to fit. So I may have to run that down a little bit in the hydraulic press to get the rest of it in here. Since I'm not pushing on it that hard to compress it any at all. This is my ram here. I'll just set that in there. And I'll take it in there, bring it down so we can fit the rest of it in there. And then we'll come back and finish it up. I guess I've got enough room to fit it in there now. Not too much left anyway, but a couple of loads. Hope I do. Goes in there like that. Okay. Like I said, I got 10 more pounds to do, but I'll do that later. And then we'll be taking these little hockey pucks, if you want to call them that. Taking them out, and they got to be thoroughly dry. Or break them up, hand break them into small pieces, reasonably small. And then we'll just keep reducing them in size till they're ready for sieving. Okay, that'll be that now. We'll go to the press room. I'll set that up on the press, and we'll take a look at it. Okay, we're in the press room. I'm all set up. I got a pretty good strain on it now. We'll be pressing it down till the top of this cylinder here comes down to the top edge of here, and that, by figuring it out with the volume of all this and everything, it comes to 1.75 centimeters per grams per cubic centimeter. And that's what we're looking for. So I just got to take this down. It's not too hard to pump yet, but it'll get difficult when it gets to that white line. Then we'll have to let it rest for a few minutes or so. You can hear it's out of the creek now. It's backing down good. It's a 12-ton press, and figuring out the square inches on top of that cylinder is about 1,000 pounds per square inch. harder now. I used to do this with my right hand. I should be on the other side, but it's all right. When it gets to a point where you just, it's just getting to be an effort to pull it down, then you have to back away and let it rest. Like so. I'll let that sit probably for 5 or maybe even 10 minutes. Probably 5 minutes. Then we'll try it again. Press it down the rest of the way. It's about finished now. I'll let it sit for maybe 5 minutes. See the edges come down to the top of this cylinder. Now we just release it. The cylinder rises back up. Take off our spacers and things. Pull the plunger out. You started off way up there. Went down that far. Then we'll take this off. Over here. It's a steamy, hot day in Florida, as you can tell. Now we'll go back out and I'll take those discs out. It's a little bit tricky to get these out. Not really tricky, but you got a certain way of doing it. First you get rid of all these hose clamps, obviously. That allows the cylinder to be spread. Because you don't want to be beating on these. It's not a good idea to ever beat on gunpowder. Even though it takes a lot to set it off. I've hit it with an anvil, with a hammer. I take a pretty good rap for it with the flame. But I don't hit on it, beat on it at all. Almost every case of problems has been, well, mostly flames, but ignition, but it's just not a good idea. You start spreading this, they start to drop out. It's supposed to. Once they start to go, it goes pretty easy. Headache. Okay. There's one. That's what they look like. Just set it in that box. Oh, that's a good. Got to put a disc between that one. That's all right. Not very enough. A little harder to break it up. That's all. Okay, there's another one. Should all be about like that. About 3/4 of an inch or less. That big one. That could be just several stuck together too. Yeah, that's what it is. I don't remember. Missing a disc. It's more like it. Okay. See ya. Dump all it in later. So it's a pretty quick way to make 10 pounds of gunpowder. The machinery does the work, so you don't have to worry about losing time with anything. Because you just put the mill run. Who cares? Do something else. There's a little bit of graining it is the biggest problem. It takes the most time. I'm always trying to devise better ways, faster ways of corning the powder, of graining it. But it's a labor-intensive operation. There's not much you can do about it. A hot day. Now what we do here is use hand right now. Break them into small pieces. They dry a lot easier. As you can see, it's not too difficult. Takes a little time, but because when they're bone dry, they're hard as pottery. It's like china pottery. You can't, like flint. That's what you need. That so they take a nice polish. Then when you tumble them for a glaze, and then, you don't want any dust in your powder, and the grains are real hard, which they should be if the density's right, and the moisture content was right when you started. You don't have any problem with it forming dust. Just works is very tolerant, it's very forgiving as far as you're just lifting shells, that's all. But if you're making gunpowder for small arms or for military or ordnance, they had a strict set of rules as far as the proof of the powder. They'd be tested in many ways, from burning to everything about it. The whole list of things they used to test. You had to pass pretty stringent tests. Throwing it away. But we don't bother with that. But I do sometimes just for the fun of it. But for fireworks, you don't need that. It's really like cannon powder, 2FA. Dust gets in your throat. Excuse me. I don't think it hurts you. I'll find out in 35 years. So, well, this will be a little time-consuming process, so I won't bore you with going through this. You get the idea. The next thing we'll do is we'll run it through the granulating machines. You'll see how that works. It's a little more. It's interesting. Kind of tedious, but it has to be done. But we'll get to that later. Now we're ready to granulate. I've got some of the powder put in this bucket. You don't want too much in close at hand, but just put in this machine here. Hopper. It's not really an easy process. This is the preliminary breaking up of the chunks into a smaller size, which you can run through this. As you can see, it breaks them up into much smaller, about that size. Some of them don't get broken up, they just go through, but too much dust. You can't help some, but you want to create as little as possible. Slow the hopper up a little bit here. Sometimes it works real smooth. Depends on the how I break them up to begin with. Some didn't get up very good. These rollers should really be bigger. It should be probably 6 or 8 inches diameter. Then your angle, where the grains go through, your angle is much more of a gradual. If you had small rolls, the angle of incense going into the thing is much steeper, and it just kind of rubs them off and wears them out. But this is okay for now. It doesn't take as long as it seems, but it is a little bit of labor, a little bit labor intensive. Everything here is aluminum. There's no danger of any sparking. I really should have a face mask on. I've got a big shield. What you really should have. Because if you've got an ignition, your problem would be burns, obviously. You get fried. So, I think I'm going to get that when we do some more. This is give you the idea of the rough breaking. When I come back, we'll get into the fine breaking. Okay, the most difficult part has been taken care of. Getting it to this size. It's That's the most difficult. Now it goes into this small mill. It's a lot simpler, as you will see. There's an adjustment right here. Turn this screw in, it makes it finer. Back it up, makes it coarser. It's a nice little machine. It just works real well. It's fast. I'll show you in a minute. Gets it down to a nice size right away. And you just work it out like this. Right into the barrel. As you can see, it goes pretty quickly. Not the first granulation takes a long time. Not a long time, but it takes quite a while. But this you can do 10 pounds in 5 minutes. Of course, it isn't finished yet, but it's down to a manageable size. So we can continue on. Of course, in the commercial mills, they have automatic series of rolls and sieves. Everything's done in one operation. Because in chunks comes out grains. All sorted and graded. But that's a pretty elaborate equipment. Okay. Seems like it's could be a little dangerous, but if you've ever tried to ignite black powder by striking it or hitting it with a hammer or something, you find it's quite difficult. In fact, I might demonstrate that in a little while, just to give you an idea. Not that I'm saying you should be blasé, reckless about it, but there's no force here that's adequate. You have trouble sometimes with machinery because of very powerful, heavy machinery in the mills. It's quite a bit different than running things by hand. The only thing you have to really stay away from is like chipping it with a chisel or something like that, where you're concentrating a lot of force on a sharp edge. That could do it. That's half the trouble they have with rockets igniting. Even whistle rockets, they say they detonate, you know. If you hit the top of that spindle with your rammer, the blow is focused on that little small area, and it very often does ignite. But the rammer striking the whole surface of the composition, you couldn't hit it hard enough. And you wouldn't want to. Why would you want to do that? You'd burst your tube or something. There's no need for that. This is a very smooth operation. Like I say, when I get bigger rolls for that mill there, that granulator, it'll be a lot easier. The roll should be twice that diameter. I don't know if you can understand what I mean, but it's if the roll is large, the entrance point where the grains enter is a lot easier to draw it through than a little small roller where it's got to suck it right in quick. It just grinds it up in the dust. So I'll work on that. Because out in a machine shop, I have access to a lot of things that the average person wouldn't have, but you can always improvise. You don't have to do this with you can break it up with a wooden mallet and a block of wood, slower. I did it for many, many years. Called a breakdown house. The girls will sit there, or guys, whatever. Blocks of hardwood and lignum vitae or oak or something, and just then tap on the blocks all day, break it up into about this size. Not the most efficient way to do it, but it was reasonably safe. And if they did have an accident, usually it was something, some gross mistake somebody made, almost always. I read of one case where the woman went, I guess their equivalent of our coffee break, in the breakdown house, she went to get some baked potatoes, and they had like a charcoal fire and they baked potatoes. She went to get one, when she came back, a spark had lodged in her apron. She didn't know it. It fell out on the floor, and it was a big woof. And several got burned to death. Of course, they had like several hundred pounds of powder in the room there. The quantity is always important. You have the big difference, well, obviously there's a big difference in 1 pound and 50 pounds, but the difference in survival is extremely important. But they had a lot of accidents in the old days. Well, not comparatively a lot, but there's a lot of different kind of people working there. Some of them had a natural sense of caution, and they never got into trouble. And then some people, no matter what you tell them, they just don't have any horse sense, I guess you call it. They do something foolish and they're in trouble. Certain things is obvious. How anyone would beat on a chisel with a hammer, even a brass chisel, a brass hammer, trying to chip hardened black powder off of a piece of equipment. It just escapes me, but it's happened. Okay, it's got to that point now. As you can see, it's kind of a deep barrel. Grains are considerably smaller now. Now, when I come back, we'll put them into the finishing process where the blocks knock around and break it down further. That test I was talking about. This is 2FA grain powder we use for lift. Just to show you that it is. I'm going to try to ignite it with a hammer, but just to show you that it's black powder. Yep. A little windy out here. Okay, now I'll try to ignite this with a hammer. Not so easy to do. This is not to be construed as perfectly safe. That, you know, you never can really tell what's going to happen with black powder. But pretty much it's difficult, very difficult. I'll have to powder it up a little bit so it won't fly all over the place. Spilling all over. Okay, I'll give it several different hits. That doesn't make it go, but yeah, it went then. That's a pretty good slam. But you get the idea. It's nothing to be callous about. There's no question about that. It's definitely possible. Like I said, in the case of a chisel or a hammer or something like that, dangerous. Kind of finished the granulation. This is what we use for the last bit of it. Just a bucket with a bunch of holes. Bucket within a bucket, a bunch of holes in the bottom and the sides. And a lot of pool balls. They're very hard. Like that. About a dozen of them in there. We just dump the powder in there and tumble it in this ball mill here. Break up the grains further and force them through those little holes. Set this up here, like so. Cover on there. Yeah. Now we'll just set that going, and probably in a couple hours it'll all be through the holes. It'll be a mixture of grains, of course, different sizes. Then we have to sift them out, and finally we wind up with dust at the end. And that can be the run back through the process. Repressing it the whole bit, or you can use it for lots of things. Priming, match. It's excellent powder. It's already been compressed, and it's just like meal powder, only it's fine dust. It's called corning dust. It has a lot of special uses. But anyway, we'll set this going. It's very noisy, so I won't stay long. All right, we're finished graining, and this is the outcome. I got 1.5 pounds of, if this is closer you can see it. Well, it's about a 2FG, I guess. More like a rifle powder or something. But it has a lot of good use for small, lifting small, like cakes and things like that. And I got 7 pounds of, well, it's really about 3 FA, I guess. That's all done there. Now it's just got to be tumbled. Maybe for 8 hours or so, I would say. Put a little polish on it, a little shine on it. You don't have to do that, but it just makes a more professional look. We won't be putting graphite on it. There's no need for that. It's just retards ignition somewhat. You never put graphite on small ounce powders of this size, small ounce powders, because the ratio of graphite to powder would be too much. There's too much graphite involved. With smaller grains, you know, with a lot more of them. So we will be putting that in the mills for about, ball mills for about 8 hours, and then there'll be have a nice shine to it, and then we'll show you that, how that looks. And the last thing we'll do is a little demonstration. We'll take 1 pound of it and see what it can do. At this time, I'd like to make a disclaimer of sorts that any of these things I'm saying, I don't advise anybody to do them. It's against the law, for one thing. You have to make up your own mind about everything. It's not my responsibility to do something and get hurt or anything. So this is just merely an instructional video. The way I do things, the way, from what I've read over the years, the way it was done commercially years ago, many years ago, and at the present time. Strictly informational. And I have a lot of other videos too that you might write and ask about, and get a list of them as to what they are, the content and everything. Just write to Stan Williams, 4117 Grand Avenue, Sebring, Florida, 33870. And I'll get that and get a list right out to you. 33872, rather. Change the zip code on it. So we'll be doing that. And the last thing we'll do, like I said, is a little demonstration of what 1 pound of black powder can do. Not that it's nothing close to flash powder, of course, but if you can find it enough, it's pretty hefty. Anyway, we'll get started with this thing now. Here's our powder, freshly made. It's been polished about 6 hours, and I coated it with 400 mesh flake aluminum. I've been trying that lately. It seems it's much better than graphite. You could put nothing at all just as well, but I've just been trying this because you know aluminum is very reactive, as you can tell by its use in flash powder, and it seems to perform very well. It makes it free-flowing, and like it doesn't clump together when you keep it stored for a long time in a jar or something, and it certainly doesn't hinder the flame spread rate or anything like that. It burns as good, if not better than ever. And I'm going to weigh out 1 pound of it. And then tonight we'll set it off electrically and see how it goes. Let me find my can for the scale here. There it is. That on there. By the way, I got 7 pounds of 2FA, 3FA like this. And 1.5 pounds of 3FG, and I got a pound there. And I got 1.5 pounds of corning dust, which I keep separate. I'll put it back in the mix. When I do some more powder, I'll just include it back in it. Take 10 pounds of that, so it's not wasted, not lost. I can use it for lots of things. Okay, that's a pound here. I'll be making a little display of that or a demonstration. I don't know, I think it's too close to the camera, you probably won't be able to see this. I get blurry. It's got kind of a grayish cast, silvery gray in the aluminum. And we'll see how it goes tonight. I think it'll go very well. As soon as it gets dark. Get ready to shoot now. Not yet. I'm going to try to follow it up. I don't know if I can. I'm going to shoot up a 4-inch shell with the same powder that we made, the very same type of powder. It's exactly the same method. We shoot that. It's pretty light, but we'll do what we can. Then I'm going to shoot a pound of it, so you can see what that does. So I'll have a countdown on the count of fire. When I say 5, 4, 3, 2, 1, fire. 5, 4, 3, 2, 1, fire. He's gone. I can't see it. Went too high. Got away from me. Anyway, you heard the blast. Okay, here's a moment of truth. This is a pound of that powder that I separated earlier. I showed you it. Got it in a plastic bucket out there. It's just going to be a big whoomph. To give you an idea. I'm going to count down 5, 4, 3, 2, 1, fire. 5, 4, 3, 2, 1, fire. Well, quite a blast, as you can see. This is some black powder that I've just finished glazing, which is a tumbling process for about 8 hours. You have to mist it carefully. If it's too dry, if it's just bone dry, it just gets frosty looking. It doesn't get this nice shine to it. And it's more than just attractive looking. There's a definite purpose. There's something about the surface of the grains. I knock them together for 8 hours under a slightly damp condition, very about 3% moisture. It enhances the surface flame spread rate between the grains. I don't know how exactly. No one does exactly how. Probably because it's a super consolidation just on the surface of the grain. When the grains knocked together, it gives it a little super. Incorporation, homogeneous, makes it just different. On the surface of the grain is very active for the spread of flame, which makes it a more explosive powder, which is a way of saying the speed at which it generates gases. I'll zoom in on this, see if you can see how the grains look. Probably couldn't see too much, but they have a nice gloss to them. It's a standard process for commercial powder. In fact, they go a step beyond this. Then after this, they glaze it very lightly with the pure graphite, which makes it really shine like little jewels. Of course, the graphite definitely inhibits the flame spread rate somewhat, not very much, but a little. In the case of firearms or cannons or that type of thing, you don't want the powder to burn too quickly because the strain on the metal of the gun is increased quite a bit. And they're trying to avoid that all the time. Of course, black powder or gunpowder, black gunpowder, in the 1800s, in the early 1900s, it was quite a popular propellant. It's been replaced since that time by nitrocellulose-based powders, which are more powerful. Just better in general, less fouling to the gun. But the black powder for centuries was the propellant of choice, but the only one they had. And it's been quite refined in its method of manufacture. It's been really brought to state of the art. Even as early as 1850, black powder was about as good as it was going to get. I think the modern companies, the only one left today that was GoEx Incorporated. They bought the plant from DuPont in 1973. I imagine anything to do with that is proprietary information. They won't tell you what they do, but I imagine they still use wheel mills, the big, huge heavy rollers to grind the powder to an intimate union. And that's the beginning of the process. Starts with the potassium nitrate, sulfur, and charcoal, all as pure as you can get them. Although today, potassium nitrate, even fertilizer grade, is very, very pure. And with sulfur, and the charcoal is very critical. That's a crucial component because that can vary so widely. The traditional woods, willow is good, alder, but this maple is excellent. Maple is what they use today for black powder. Always popular, any white, very non-resinous wood, such as the ones I've mentioned. Woods like pine or oak are no good because there's too much resinous material in them, and when you pyrolyze it, it leaves a lot of minerals and ash and stuff. It's just not good. But just as important as the type of wood is how you pyrolyze it or roast it. You should roast it at the lowest temperature possible. In other words, you keep it about 500 degrees in your kiln, and there's an exothermic reaction. When it reaches a certain temperature, the charcoal takes off by itself. It generates its own heat. So at that time, you want to kill your fire just about. Just keep it very low. And when the pyrolyzing process is over, the wood will be just intact. Pieces will be just like you put them in the barrel. There'll be sticks and branches in the same configuration. If you overheat it, the charcoal, you ruin it. You don't ruin it, but you greatly affect the inflammability temperature. In other words, charcoal is pyrolyzed at say 1800 degrees. It takes twice as high a temperature to ignite it as charcoal pyrolyzed at 500 degrees. Of course, this affects the combustibility of the gunpowder. Combustion rate is the rate at which the powder burns. One grain burns in concentric layers. If you had a grain as big as your fist, and you ignited it, it would burn progressively smaller and smaller until it was gone. It would be very quickly, but still nothing like, grain powder. And this is a combustion rate, and that wants to be as good as you can get it. And that's a matter of incorporation, proper ingredients, and all that. And the flame spread rate is the rate of flame spreading between the grains. This can vary quite a bit by the method of manufacture, the type of charcoal, the flammability, temperature again. Naturally, a charcoal that inflames at 700 degrees is going to make it much faster gunpowder than charcoal that inflames at say 1100 or 1000 degrees. This is why it's important the way you pyrolyze the charcoal. And the larger the grains, the easier the flame has to spread between them, but the smaller the grains, there's more surface area, so much more sudden release of gas pressure, which is sometimes you don't want that. But one kind of offsets the other. A powder that has, say, a low combustibility or a low combustion rate, but may have a high flame spread rate with larger grains because the flame gets between the grains much more easily. That can offset the lack of combustibility. But generally speaking, you make the powder as combustible as you can. Then you can adjust the flame spread rate of the explosiveness of the powder, which is just a function of the combustion rate and the flame spread rate. You can adjust that by either graphite coating, size of the grains, things of that nature. And it's an interesting story, but involved. You can really get into it. But anyway, that's the way it works. This is the Brandywine River. We're looking upstream at the third falls down. Beautiful river, kind of noisy. Across the way is a cotton mill, old revised cotton mill. It's something else now. And they're coming around to the main parking lot, the main office building, made of blue granite, quarried right here in the site. Now we're panning around the parking lot again. There's the white buses that take people up the dirt road by the lines of mill pairs and various buildings, machine shop, different things. Beautiful forested area, very hilly. The Brandywine River drops 125 feet in 5 miles, so there's tremendous stores of energy, which is why they're located here.
This is a little panoramic scene. It's a mock-up of the whole site here. Little trees, and there's the Brandywine River winding down, or wending its way down, I guess, through the hills. It's pretty accurately done. It's in the main display room. There's all kinds of pictures on the wall and things. This here is a model of an old flour grinding mill. There's the main stone for flour, which is different than black powder stones. They're horizontal instead of vertical, and they draw tremendous friction with grooves in them, and the flour works its way from the center to the outside and is ground into a fine flour. Different principle in if you ground black powder that way, it'd blow it up, but it works fine with flour. See that stone against the wall there. And all kinds of implements. This is a geared device. The gears are all made of wood, hardwood, oak, I believe. Very finely finished. It's quite a thing. There's the various principles. There's meshing gears, bevel gears, rack and pinion, different things. This is a model of the water wheels. This is called the undershot wheel, where the stream just runs under the mill wheel. This is a breast wheel where the water flows a little higher than center. And this is an overshot wheel, which is the most efficient, most powerful, but you have to have a large head of water. This is a water turbine, which came into being about 1850, I guess. DuPont started using these. They're about 90% efficient. They're excellent. The water runs from the mill race down the sluice way into the turbine, which turns bevel gears, and the line shaft runs to the pair of mill houses. I'll show you that in a minute. There's the Brandywine River again. Even in this shallow and the very calm area, you can see that it's a pretty active river. It's moving quite rapidly. And this is woods around it. Now we're looking at the second falls. There's 3 sets of falls. The water is dropping in stages. Each one gives a different level for the mill race backed up to the shore, where you can draw water off from and run down to the mill stream again. This is an old derelict mill pair of buildings, pair of mill buildings rather. They're just ruins.